Hello, this is Dr. Odom doing his Selected Islands Outside of the Caribbean podcast for BIOL2462 Caribbean Island Ecology. So my islands today will be Madagascar, New Guinea, the Galapagos Islands and the Hawaiian Islands. I'm going to do a separate podcast for each because the software that we have doesn't really like too long a file, so it won't work if we have too long. So I will do 4 separate podcasts, one for each island. And the first island is Madagascar. So what I want to do with these different podcasts is to go through, give you an idea of what the biota is like in each of the islands, give you an idea of the history of the islands, and try and bring forward why we get the different types of biota on these islands, using or explaining it through things which we have looked at before in lectures in Caribbean island ecology. So our first island is Madagascar. It's an oceanic continental island. It's a large island separated from the mainland for a very long time. So oceanic continental island, it's a bit of a contradiction in terms, but we call it oceanic island because it has characteristics in the biota of an oceanic island in that it has high levels of endemism. Now this is unusual for islands which have been joined on to a continent in the past, such as Madagascar has. But because Madagascar has been isolated from a continent for such a long time, natural selection and therefore evolution has converted or changed that continental biota into something completely different with high levels of endemism, which we would normally associate with an oceanic island. So Madagascar has species of vicariant origin. In other words, those are the continental species which existed on the island when it split away from the continent. And it has species of dispersal origin. So these species are the ones which arrived on Madagascar after the island split away from the continent. So these species of dispersal origin had to disperse across water to reach Madagascar. So because it has been isolated for such a long time, at least some species have made it across. So there is Madagascar's geological history. 170 million years ago, Madagascar was nestled in the middle of Gondwana, which was the supercontinent, which made up the landmass in the southern hemisphere in the surface of the Earth 170 million years ago. About 162 million years ago, Gondwana split up. South America and Africa went off on their way, and India, Antarctica and Australia headed off in their way. Madagascar was right on the boundary, but it was joined on to India, Antarctica and Australia. About 30 million years later, at around 135 million years ago, South America and Africa continued on their way, and India and Madagascar began to split away from Antarctica and Australia. Fast forward again to another 100 million years ago, South America and Africa have begun to break up. So we're seeing pretty much the shapes as we see them today. North America still hasn't joined up to South America yet. But India has begun to move northwards, and Madagascar is still part of India. Australia is still there attached to Antarctica. 88 million years ago, and Madagascar finally becomes an island all to itself. It splits away from India and India begins to drift northwards while Madagascar stays in the position that it's in at the moment. So 60 million years ago, India is well and truly sprinted away to the north. Madagascar is in pretty much the same location that it is today in relation to Africa. So the last time Madagascar was connected to a subcontinent was India, was about 88 million years ago. So Madagascar is a large island. It's 582 square kilometers, 582,000 square kilometers. To put that into context, Trinidad is about 5,000 square kilometers. So Madagascar is 100 times bigger. It's located 400 kilometers off the east coast of Africa at about 30 degrees south of the equator. So it's in the tropical zone, or extends into the tropical zone, and along its east coast it gets a lot of trade winds bringing moisture in. So it's quite wet along the east coast, but on the west coast it tends to be much drier. It's been isolated from Gondwana for about 160 million years, and it's been separated from India for about 88 million years. So when it split off, it had a continental biota, and that continental biota, the Gondwanan continental biota, has changed now. It's been through natural selection, it has changed to something which largely consists of endemic species, and the biota has been supplemented by dispersal biota, so plants and animals which have arrived on Madagascar subsequent to its separation. Madagascar has very high levels of endemism, and that's purely down to its long period of isolation. So it's had a lot of time for new species to evolve, and that's what makes people call Madagascar more of an oceanic island. So there's Madagascar, fairly close off the coast of Africa, although still far enough away that it's out of line of sight. So people in Africa didn't really think about trying to sail to the east and colonize Madagascar. It's also the reason why Africans didn't colonize Madagascar is that the ocean currents and the wind currents tend to come from the east. So we have our trade winds, and we have the circumpolar current, circumequatorial current, which comes from the east, and that would have brought people and vessels from the east. So Madagascar has actually been colonized by people from Southeast Asia rather than from Africa. So Madagascan peoples tend to be derived from Southeast Asia rather than Africa. Other species have island hopped across these archipelagos. This is the Comoros Island, and reached Madagascar in the past. So Madagascar, as I said, is fairly moist along the east coast, so it supports a tropical rainforest, subtropical and tropical rainforest, much of which has been now cleared through human activities. The dark green areas are where the tropical rainforest still exists. The light green areas are areas where tropical rainforest did exist but have now been cleared by people. The peachy color is savanna, and that mainly represents cleared dry forest, because Madagascar tended to be covered with forest, either humid rainforest or dry forest. And when humans arrived, they began clearing the dry forest to form pasture and savannas, and they burn those areas pretty much every year, so that retards any sort of recolonization by forests. And with that continuous burning, the soils have been degraded, so it's very difficult for any of those dry forests to recolonize. So Madagascar is covered in forest, rainforests, and dry forests. A couple of pictures of those. And a lot of the species of plants and animals in those forests are very weird and wonderful and unusual and endemic. These are elephant trees in some of the dry forests to the south of Madagascar. And here's a typical xerophytic scrub forest. Many of these species are only found in Madagascar. They are endemic. Madagascar is most well known for its endemic fauna, and here we have the lemurs. The lemurs, as depicted in that show, Madagascar 1, 2, and 3, they are descended from prosimians, which still exist in Africa today. They would have been part of the continental Gondwanan biota, which Madagascar was bequeathed when it split away from the continent. In Madagascar, those prosimians evolved into lemurs. In Africa, those prosimians evolved into monkeys and into apes, and eventually into us. So these lemurs, maybe we can call them our very distant cousins. Very pumpkin vine. There are other species of animals on Madagascar. Chameleons occur there in great diversity. Interestingly, it's probably chameleons who are a good example of a dispersal species of dispersal origin. Chameleons also occur in Africa, and they probably originated in Africa and dispersed across the Mozambique Channel to Madagascar. The species richness of chameleons is highest in Madagascar, and scientists believe that is because of adaptive radiation. The chameleons spread into many different vacant niches. This tortoise here is the radiated tortoise. It is one of the rarest tortoises in the world. Its main habitat is dry forest, and because large areas of that dry forest have been cleared, the radiated tortoise is in a lot of trouble. And here we have a very colourful looking frog. It's probably endemic. I don't really know the story behind that one. And there are also large numbers of endemic trees, like that elephant tree that we saw in a previous slide. And I think this is a relative of that tree, but a bit smaller. So, human impacts on Madagascar. Humans have really cleared large areas of Madagascar. Humans colonized Madagascar relatively late. I think it was only maybe 4,000 to 5,000 years ago, but they have been very active since then and have cleared much of the natural vegetation that used to be found in Madagascar. The means of cultivation reflects the origin of the people. You see a lot of paddy fields, much like you would find in Southeast Asia. Here is some of the erosion which is occurring in the interior of Madagascar, brought on by burning and pasture practices which severely degrade the soils and cause this mass wastage. Here we can see a picture of humans progressively chopping away at the tropical forests in Madagascar. Here down below you can see paddy fields, and farmers are moving up the hillsides into the untouched forest and gradually clearing it and converting it into agricultural areas. So that's a bit of a problem in Madagascar. A lot of the ecosystems have already been cleared, and the ones which are remaining are still under threat. Because of the very high levels of endemism, once a species is lost in Madagascar, it is lost for good. So Madagascar has some of the most critical conservation issues on Earth today. So that's Madagascar. I'm going to end this podcast now, and maybe it will actually compile. My next podcast will be on New Guinea.